All right, let's do this starter. Here's what's given. Vector A is 20 meters at 25 degrees. Vector B is equal to 50 meters at 100 degrees. And so we want to add them together, and then we want to do this crazy thing. What is 2 times A minus B? What is that equal to? So let's do part A first. And we'll actually use some of part A to do part B, to make part B a lot easier. And I like to set up vectors when I add them like this. A plus B. Well, if you say 20 meters at 25 degrees plus 50 meters at 100 degrees, if you add this together and say it's 70 meters at 175 degrees, okay, you will, I award you 0 points, and may God have mercy on your soul. Okay, you cannot add vectors together in polar coordinates. You have to turn them into what kind of coordinates? Rectangular. Yeah, rectangular. So let's do that. Have you seen that Adam Chandler movie? Okay, I showed you guys, didn't I? Anyway. 20 meters at cosine of 25 degrees. 20 meters at and the sine of 25 degrees. Plus 50 meters cosine 100 degrees. 50 meters sine of 100 degrees. Now I'm going to go ahead and do the math, because see, this will be the x components and this will be the y components. So if I give you vectors in polar coordinates, the x component is always the magnitude of the vector times the cosine of its angle. So let's evaluate this. So I get my calculator out, and it's kind of tedious. Sorry. 20 times the cosine of 25. And I got 18.1 meters. 20 times the sine of 25 degrees. And I get 8.5 or 8.45. And then we'll do this one. 50 times the cosine of 100. And we get negative 8.68 meters. And then 50 times the sine of 100 degrees. And I get 49.2. Okay. Sorry that's so small in the back room. Now I can add these so now all I need to do is add these together. So let me zoom in. So this is vector A, and this is vector B right here in rectangular coordinates. So we can add AX and BX, so I'm going to go 18.1 minus, now I'm adding them, but this is a negative, so minus 8.68, and I get 9. We can just call it No, 9.42. It's probably not. I'm being pretty careless with significant figures here. Oh, meters. And then 8.45 plus 49.2 equals 57.7 meters. Now, this is my result. That's my resultant vector in rectangular coordinates. Now, I'm just going to convert those back to polar coordinates. So let me zoom back out. So I'm going to say that r is equal to the square root of the x component squared plus the y component squared. Take the square root, and we'll round it off to two significant figures, and it should be right even though I've been messing around. So 9.42 squared plus 57.7 squared equals, and I get this big, I don't know if you can see it there. Yeah, there we go. Now, what I do now, like the square root is like raised to the power of 0.5. So on my little calculator here, I hit the little caret button. I'm going to do this, and then I hit 0.5 equals, and that's the same as taking the square root. And you get 58.5. Degrees. And then the angle is the inverse tangent of the y value over the x value. So theta is equal to the inverse tangent. Second tangent is inverse tangent. 57.7 divided by 9.42, close parentheses, equals, and you get 80.7 degrees. Did you get that? Yeah. Question? Oh, it should be in meters. Thank you. I was just testing you. All right. So we can say vector r is equal to 58.5 meters at 80.7 degrees. Thank you for fixing that. Okay. And then for part B, well, I've already got A and B in rectangular coordinates. Now, if this was a completely separate problem, you would have to change whatever's given from polar into rectangular. But they're already in rectangular. So what I'm going to do is I'm going to go A, or I'm sorry, 2 times A minus B. Well, that's going to be equal to 2 times 18.1 meters, 8.45 meters, minus negative 8.68 meters and 49.2 meters. Okay. Well, let's go ahead and do this. What's 2 times 18.1? Well, I think that's 36.2. And what's 2 times 8.45? I think that's going to be 16.9. I think that's right. And then we're going to subtract B. Well, you subtract a negative, let's subtract B. So that's going to be minus negative 8. So I'm just going to say add 8.68. And then minus 49.2. And now we can do it. So 36.2 plus 8.68 equals, this is 44.9 meters, and 16.9 minus 49.2 equals negative 32.3 meters. Now let's go ahead and do Pythagorean Theorem, see. And I'm just going to do, see, 44.9 squared plus 32.3 squared equals, then raise it to the power of 0.5, and I get 55.3. meters. Now we're going to use inverse tangent. Second inverse tangent, and I'm going to put negative, this is the y value, so it's the y value, negative 32.3 divided by 44.9, close parentheses, equals, now I get negative 35.7 degrees. Should I add 180 degrees to that answer? Under what circumstance do I add 180 degrees to my answer after using inverse tangent? What has to be true? Yeah, x is negative. Is x negative here? No, what is negative? The y value is negative. So, no, we're good. This is good. So I can say, well, the theta for r is equal to negative 35.7 degrees. And there's my answer. Now, one thing I didn't do here is I didn't draw a sketch to check my answer. So let's do that. And I'm just going to start here. And I say 20 meters at 25 degrees. So let's say that's 20 meters. So there's A plus B. Well, B would be like twice as long, and then like something like this. And 100 degrees, right? That's this is 90, so it'd be 10 more. So if this is A plus B, and so here would be R. There's my resultant vector. So I'm just drawing a sketch of this. And does this R match over here? Yeah, a little bit longer than this. And then 80.7, yeah, it looks like about 80 degrees. So you can use your sketch to check your answer. Now what about this? This sketch is going to be a little bit harder. 2A minus B. So I'm going to draw it right in here. So here's 2A. So 1A, 2A. Now minus B, and well, B is like kind of like this. 50 at 100 degrees, it'd be kind of up like that. But this is going to be plus negative B, right? So here's negative B. I think that would, see if this is 20, I think it should be a little bit longer. So I'm just kind of guesstimating how long to make this, right? If this is 20, 40, this should be 20, 40, 50. So it's 50, and then 100 degrees. Well, 100 degrees would be 10 like this, but then I have to go the opposite direction. So something like that. So here's R. So like 20, 40, 58. Yeah, I mean, it looks about, or 50. Yeah, that looks reasonable compared to this answer. This angle, negative 35, does that look like it could be negative 35? Yeah, that looks reasonable. So what I want you to do is draw a little sketch to check to see if the answer you got is reasonable. Because sometimes you leave your calculator in what? From your math class. Radians. And you get bizarro answers if you do that. And if you get bizarro answers and you look at your sketch and go, whoa, wait a minute, and then you can fix your mistake. Okay, any questions? That is all.